Hey everyone, today we're going to be looking at the top most common mistakes that I see people make with Vectric software. And if you don't know who I am, my name is Kyle Ely and I teach Vectric in my online programs called Learn Your CNC Academy. I've helped train over 6,000 students already, and I've seen lots of mistakes being made with those students. And today I'm going to summarize those top 10 mistakes in this video to hopefully help you avoid making those mistakes. And if you want to learn more about my Vectric training programs, you can check those links out down in the description if you really want to take your Vectric skills to the next level. But let's get started, and we're going to be covering our first mistake, and that is forgetting to set your material size correctly. This is a very common mistake people make when they're first starting out. Even when you get more experience, you still may forget this step, but when you are first setting up your job, it is critical that you set up your job size correctly. Now, this may seem very basic, but this will make a big difference whether your project is successful or not. So here's an example. I'm setting up a job 12 by 12 inches, and my material thickness is set to 1 inch. And also pay attention to your zero positions. But once you have that all set up, if we go check out what this looks like on your CNC machine, it's going to look something like this. So you can see the workpiece that we're working with is 12 by 12. And is exactly 1 inch thick. The thickness is the most critical in most cases to get your toolpath correct, because if this material thickness is different from what you enter into Vectric, that will make a big difference whether or not your toolpaths will cut correctly. You may have even experienced this if you've been using CNCs for a while. Your machine actually cuts into your spoil board below your material, and a lot of times that is caused by either having the incorrect material thickness set up or having your zero not zeroed correctly on your machine. So keep that in mind whenever you're working with material. Measure it very accurately, and it's even more useful if you have a digital caliper or set of calipers that you can measure the thickness of your material, because that will produce a much better result if you have that entered in as accurately as possible. And that takes us to our second mistake that I see very commonly, and that is not zeroing your Z-axis at the correct location. So you'll notice when you set up a project, you're going to have two options for setting up your Z0 position. That is going to be on the material surface at the top, or on the machine bed, which is going to be below your material. Both of those are going to allow you for zeroing at a different location. Sometimes you may want to use one over the other. Some common things that I would use the material surface zero position for is if you're doing pockets or VCarving or inlays or anything on the surface of your material where the thickness of your material is not as critical. And then the times I would use the machine bed as my zero position is if I'm machining all the way through the material with a bunch of profile cuts. Or let's say you're doing a 3D carve and your material surface is going to be all removed away. You may want to zero off of the machine bed. That way you have a consistent zero location you can always reference from. Now I will tell you this, if you zero off the material surface, your thickness is not going to be as critical to get it exact. And that's because you're referencing from that top surface. If you zero off of your machine bed, that's going to be when it's going to be more critical to get that thickness more accurate, because your Vectric software is zeroing from the bottom of your material, so it will be referencing from the thickness that you have entered into Vectric. So if that's incorrect, your toolpath depths are going to be incorrect. And we could take a look at that in a machine example. This 1 inch thickness that we have set here, if this was correct, and if you were zeroing off of the material surface in the lower left corner, this is exactly how you would zero this. And like I said, if your material thickness was a little bit off, let's take this material and make it a little bit thicker as an example. So now it is greater than 1 inch, and you can see now it's 1 3/16. So that 3/16 difference would be made up for when you zero this off of the material surface. So this would now be zeroed up here at that top surface. And your carving would not have an effect if you're just machining on the surface of that material. For example, a pocket, a V-carving, or an inlay, anything like that in the top surface will not be affected. the depth will still stay the same as you programmed it in Vectric. However, if you had a profile cut cutting all the way through your material, it's only going to cut that 1 inch depth that you set it in Vectric, and then that extra material is going to be left over at the bottom. That's when the issue would come into play. Now, if we look at this from a different perspective, if you were to zero this tool off of the machine bed instead, inside of Vectric, then your zero location, if we move this down to the bottom, would look more like that. And if we set this job in Vectric as being 1 inch thick, that extra material is going to be at the top now, and Vectric's not going to know that extra material is there. So if you don't have your bit raising up high enough to clear that, you're going to have issues with it crashing into that top surface material. And then another thing you're going to have is if you do any pockets or any cuts on the surface of the material, it's not going to be cutting the correct depth because of that extra material that is now above the material where you set it in Vectric. So if I were to put a guideline here at 1 inch in thickness, right here is all the extra material above. So this is the 1 inch mark. That's where Vectric thinks your material top surface is, because that's what you entered in Vectric, and it's not going to know all this extra materials here. And then, like I said, if you have a pocket set up to cut a 1/2 inch deep, it would be referencing from this line at a 1/2 inch. So it'll cut down to here, and you will see if we measure this from this top surface to here is 1 inch. And that is what we set Vectric to set up as. And then from here to here, it's still cutting that 1/2 inch depth like we programmed it. But if your material is actually thicker than what's shown here, you could see the depth is actually going to be greater. And that's all because we're referencing from the bottom of your material, which is your machine bed. So hopefully you understand that a little bit better and keep those 2 tips in mind when you are setting up your jobs and when you're setting up your zero location inside of Vectric software. Now, mistake number 3 that I see a lot of people make is using the wrong tool for the job. Now, as you may know, there's many different CNC bits that you can choose from. There's end mills, there's ball nose bits, there's compression bits, V bits, tapered ball nose, there's surfacing bits, there's all types of bits and many different ones to choose from. And when you're first starting out with Vectric, it's going to be really hard to determine which bit you actually need to use for each job. Each bit has their own specific purposes and also depends on the material you're using. So many different options you can choose from, whether or not your project is going to turn out as a good result or a bad result. So a lot of this is going to come with experience. The more you use the tools, the more you're going to recognize when you should use them and when you should not use them. And if you're just starting out and you're not sure when to use which tools, I do have a Vectric Toolpath cheat sheet that I made that tells you which tools can be used for each different toolpath. This is a free download you can get. I'll link it down in the description if you want to check that out for more information on selecting the right tools for your jobs. And speaking of toolpaths, that brings us to our next mistake that I see commonly made, and that is not previewing the toolpath before running your job. And this could even be that you do preview it, but you may not be previewing it closely enough. And I'll show you what I mean by that in this example of a 3D model that I created. And you'll see we have 3 different toolpaths for this job. We have a 3D roughing, 3D finish, and a profile toolpath. So if we go to our preview toolpath option and click preview all toolpaths, you can see there's the 3D roughing. After that's done, it's going to do the 3D finish toolpath. And then when that is complete, it's going to do a final profile cut to cut the shape out. And if we look at this when it's done, it looks really good. And in most cases, you would be thinking that this is going to be all good and you're ready to cut this out. So you'll go ahead and save your toolpath and run it on your machine, only to find out when you run it on your machine, there's going to be issues that you're going to come across. Those issues could have been found if we looked at this toolpath a little bit closer and slowed things down a bit. So when I'm doing a job like this, I like to preview it just like we did here, just to make sure the final result is where we want it, which this does look great. I would be happy if it carved just like this. However, after I do that preview of what the final result looks like, I want to take a better, closer inspection to make sure I'm not going to have any issues with the toolpaths crashing into things, cutting too deep, or doing something they're not supposed to be doing. This is going to be another one of those things that come with experience, but as you preview these, you can see we can reset the preview, and now if we wanted to, we can preview them one at a time. And that's what I like to do just so I can take a closer look. Not only that, up in the top where it says Toolpaths, if you go to Preview Simulation Quality, it's going to be default to standard. If you turn this up to a higher quality, this will preview the toolpath at a much higher quality. Now, if you have a slow computer, this might slow it down a little bit, but this is just the preview quality, and it's going to be much better quality if you turn this up. So you see, if I turn this up to maximum and take a look at that first toolpath, the 3D roughing, you can click preview, and not only can you change the quality, you'll see the quality is going to slow down a little bit. You can also change the speed slider here in the toolpath preview settings. And by slowing this down, it allows you to take a better, closer look at what this toolpath is actually doing. If you don't see this tool showing up in your 3D preview, you want to make sure the Draw Tool option is turned on, and also the Animate Preview option is turned on in your preview toolpath settings. Also, if you're using an older version before version 12, you're not going to be able to move your view as it's previewing. So version 12 and above, you can actually zoom in, take a better look. You can move around your view to be able to keep an eye on everything as it's previewing. That's a really nice feature that they added in version 12. So we can speed this back up. And also, if it's going very slow for you and you have to abort this preview, you can click the red X down in the lower right corner. That's going to stop your 3D preview. And then if you want to change your simulation quality and turn it down a little bit to have it go a little faster, you can do that. It will reset every time you change that quality. Now we can preview that 3D roughing again, and you'll see this will preview much faster. So as we're previewing this, you can see this one does not look bad. It's cutting one depth per pass, and it's doing multiple passes. That's how we have it set up in the toolpath. It's cutting at a raster 45-degree angle, and everything's looking good. This is with a larger 1/4-inch end mill. So with this, I think it's going to be okay. Nothing looks out of place there. No really deep cuts or anything like that. So I would be happy with running that toolpath. Now let's go to our next toolpath, which is the 3D Finish toolpath. This is going to be with a smaller 16th-inch tapered ball nose. So this smaller bit, anytime you're using that smaller bit, you want to make sure you don't cut really deep in any areas in one full depth pass. And if you're familiar with 3D Finish toolpaths, they always cut in one full depth pass. So any deep parts you're gonna have to be careful of. This is a very common thing that I see happen where people break bits or ruin a project because they were not paying attention to this. So if we slow down the preview again and click preview for the second toolpath, you can see this is starting at the bottom. And although it looks okay, if you take a closer look, you can see when it gets to the edge of the project, it's going over the side. You can even slow this down more if you need to. And you can see the bit travels across the surface and then drops down the full depth of that cut. And not only cuts that really deep, but also cuts the sidewall. You can see this really tall sidewall here. It's cutting all of that at the same time every time it plunges across the bottom of the edge of that sign. And on both sides it's doing that. So that's going to be very stressful for that tool. Not only that, if the cutting flutes are not tall enough on that, it's also going to be rubbing on the side here where it's really deep and could cause burning or even start a fire. So you have to be very careful of that. So this I would consider as not a good technique for this specific toolpath. So right there, like I said before, when we previewed it, it looked fine from an overall view, but now that we're looking at this closer and slowing down and zooming in to those locations, we can see this is going to be a big issue when it comes time to actually run this toolpath. If you ever ran a toolpath like this, you would know the issues that causes when it goes over the edge like that. It's going to make a real loud noise every time it cuts into that deeper part, especially if this is a hardwood or something. You're most likely going to break the bit or ruin the project. And if your machine is not really sturdy, you can also cause your machine to skip a step or something. and then your quality is not going to be up to par with what you're looking for. So what we want to do is get rid of this tool going over the edge like it is now, because we have a profile toolpath at the end that cuts that edge anyways. So we do not need this to go over the edge. So what I would do in this case is I would stop the preview and then double click on that toolpath to open it up, figure out what the issue is. In most cases with a toolpath like this, it's this boundary offset number here. So you would either have to get rid of that, set it to 0, or set it lower than what you have already. And I'm just going to get rid of it and set it to 0, and then go ahead and calculate the toolpath again. After that toolpath is calculated, you're going to be able to see if there's any changes made. You can see already that the toolpath preview is not showing that toolpath going over the edge at all. Now it's staying above the surface. This is another really good way to see if you have really deep parts of your toolpath. You can turn on the check mark next to the toolpath to turn on the visibility and take a look at it in the 3D view to see if there's any really deep parts of that toolpath. This looks much better now. So what we can do is you can actually click undo last, and it'll undo that last preview that we just saw. And now we can select that toolpath again, click preview selected toolpath. And if we take a better look at this now, you can see it's no longer going really deep in those edges of the sign. So now we can speed it up if we need to. And this looks much more reasonable. It's no longer plunging real deep, and it's no longer cutting to those sidewalls. You can see it just caught that little sidewall there. So that might be another issue we need to fix. And that could be fixed by putting an offset bigger on the roughing toolpath. But as you can see, we wouldn't have seen that if we did not zoom in and slow down the toolpath to take a better look. So this is what I recommend anytime you're dealing with toolpaths that you're not sure of, or a new project, or a toolpath that's going to take a really long time to cut, because you don't want those to mess up halfway through a really long carve. We're going to let this preview all the way through and keep an eye on it as it's going through. You can see after that's done, we can also zoom in, take a look, make sure nothing cut out of the ordinary or real deep or anything like that. The only issue I saw this time was that little bit of a sidewall that it caught right here in this corner. I don't think it'd be a huge issue, but we could fix that by setting the roughing with a larger offset. But other than that, this looks really good. Now that you're happy with it, then we can double check the last toolpath, which in this case is a profile toolpath, and you can slow this one down and preview, and you could see this one is going to cut out the outside. And you can speed it up however you need to. It's going to do multiple passes and cut that final shape out. So this one is one I'm happy with. I think that'll be fine. You can always add tabs or anything else you need to, but previewing those toolpaths really closely like that is going to help you find those mistakes and allow you to save yourself lots of headaches and broken bits. And we all know we don't like to break bits. So if you can avoid that, definitely take the extra time to take a look at those toolpaths a little bit closer. And now that brings us to our next common mistake that I see people make, and that is running toolpaths without setting the correct feed and speeds for that specific tool. This is another one of those topics that is going to vary widely and also be based on experience. It is hard to recommend exact feed and speeds that is going to work for everyone's situation. Every machine, every material, and every setup is all a little bit different. So there's no set answer that's going to answer this 100%. However, there is a great way to get as close as you can the first try and then alter it from there if you need to. And that is by going to the manufacturer's website or wherever you purchased your CNC bits. And a lot of those, if you scroll down on their pages, you will see a download section that has the feed and speeds chart. If you click on that, this is going to give you different tools that you can set up for, different diameters of the tools, different materials that you can set it up for, and recommended feed and speed options. Now you do have to be careful with these feed and speeds. As you can see in the top right corner, this is for industrial setups. So a lot of these feed and speeds are not going to be as useful for those of you using a smaller hobby machine. You can use it as a general reference. However, just be careful you don't go too fast, and you also have to be careful you don't go too slow. One common thing I see people make is slowing down their toolpath because they're afraid to break the bit. However, going too slow is actually really dangerous for your bits as well. And the reason for that is the slower you go, the more friction is going to build up on that bit and the more heat it's going to generate. And that heat is what really kills your bits and makes the sharpness and durability wear out very fast. Not only that, that heat is going to transfer to your collet, and that's also going to wear your collet down. Most people don't know that collet needs to be replaced every once in a while as well. Because of that heat getting cooled and heating and cooled and heating, it's going to really break down that material. So the less heat you generate on your bits, the better and longer they're going to last. And the best way to reduce the heat buildup on your bit is to run those toolpaths faster. So in reality, your goal should be to cut as fast as you can without causing issues or breaking bits. Now that sounds backwards for those of you getting started, because I know when I started, I always try to run as slow as I can. I wasn't concerned about how long it took. However, what I didn't know is by going so slow, I was wearing down my bits. And then when I did future projects, they just didn't turn out as well as I wanted them to. And I didn't know the cause was because I was cutting too slow. So what I would recommend is checking out these feed and speed settings from these different manufacturers, see what they recommend. You can see some of them get pretty high, like 345 inches per minute. Most hobby machines are not going to be able to handle those. But this is also a larger bit that most hobby machines are not going to be running either. So I would stick more with the smaller bits, like 1/4 inch diameter or less. And you see this one recommends 180 inches per minute in wood or plywood. If your machine can handle that, that's great, go for it. If your machine cannot handle those speeds, then dial it down just a little bit, but try not to go too slow like I mentioned. And a little trick is if you have to slow it down a little bit, you can reduce your cut depth per pass, which will be easier on your machine. So if you have a hobby machine that can't handle these speeds, at least you can run a smaller depth per pass, which will allow you to run a little bit faster, rather than trying to cut a really deep pass at a really slow feed rate. So those are some things to keep in mind. You will have to study up on these and get some experience with a lot of practice. Like I said, there's no one answer to answer everyone's speed and feed questions. So practice, practice, practice. That's going to make it a lot easier for you to get a little bit better at that as you get more experience. Now let's go to mistake number 6 that I see people commonly make with Vectric, and that is forgetting to add tabs or making them too small. And this is going to be if you use tabs or not. Some people love tabs, some people hate tabs, and some people don't even know about what tabs are. I personally try to stay away from tabs when I can, but when I do need them, they come in really handy. I'll show you some tips on using tabs. And if you don't know what tabs are, they are basically little bridges that hold your material in place after you're done cutting it out. And then you have to clean those up later to be able to remove your parts from your material. And they are in the 2D profile toolpath. If you were to cut an object out, you'll see if I do this toolpath cutting all the way through with no tabs added, I'll just calculate this and click preview. It's going to cut all of our parts out, but as you'll see, especially with the smaller parts, like the middle of this letter A, those pieces are going to want to break free and possibly cause some issues when they pop out of there. Or they even get sucked up in your dust collection and maybe clog up your dust collection hose or something like that. But these can all cause issues as you're cutting those smaller parts out. If you have certain hold down methods like double-sided tape, tape and super glue method, or sometimes even a vacuum table, that can help hold some of these parts. But sometimes even with those methods, when you get a really small part, it could cause issues with them breaking free. So that's when tabs are going to come in place to keep those parts held in place and not cause issues when you're cutting all the way through your material. So the way to add tabs is to go to your 2D view and open up your profile toolpath, and there's going to be an option that says add tabs to toolpath. You're going to select that, and you can specify the length and thickness here. These you don't want too big because it's going to cause you to have more cleanup work later, but you also don't want them too small because then they will break easily and they may even break before you cut your toolpath all the way out. So you're going to have some kind of balance there where you make them big enough to hold, but not too big where it's going to cause you cleanup issues later. If you're worried about them, then bigger is going to be better in this case. it just causes you more cleanup work later. But if you make them too small, I've had issues, especially in solid wood, where they break before I even finish cutting the toolpath, and then those tabs are kind of useless because they already broke. So just be careful of that. And once you set up your size, I typically go a length of 1/2 inch to 3/4 if it's a material I know it's going to hold well. If it's a material that I'm worried about, I'll go a little bit bigger for the length. And then thickness, I usually go at least 1/8 of an inch. And then, like I said, if I'm more worried about it, I can go bigger. Sometimes I even go up to 1/4 inch. So you can decide the size that you like for your tabs. And then to place them into a location, you're going to click the Edit Tabs button. There is a form here to automatically set them up. And you can set up an exact number you wanted, let's say 4. And you can avoid the corners and curve regions. And then you can click Add Tabs. And you'll see if you're using text, it's going to give you this message letting you know you have to convert it to vectors first. So I'm going to click Yes to convert it. And now you can see those tabs been automatically generated. However, I would highly recommend to double check these and make sure they're in a location it's going to be easy for you to clean up later. For example, you want to stay away from any sharp corners like this or any tight corners where it's going to be hard to clean those up. So this one I would not want. So you can either click on those to remove them, or you can click on the tab and drag it to a new location. Typically I would like to put them in a long stretch somewhere in the middle where it's easier to get access to those. I want to stay away from corners or any areas that's going to be hard to clean up. And typically the way I would clean these is with a flush trim router bit on either a router table or a handheld router. So you can go through each part and individually place these tabs wherever you like. Also, if you have two parts that are close together to another, you can put a tab close like that where they line up. That way there is a bridge going all the way across between those two cut out shapes. That's going to help hold that better. So keep that in mind whenever you're adding tabs like this and you have parts close together. You want to make sure everything's going to be held together. Even this part here, we can line these up a little bit better, one above the other. That way it's going to be a little bit stronger in that location. So of course, the more tabs you add, the stronger it's going to hold. However, that's going to also be more cleanup work you have to do later. So keep that in mind. Here's another example where I would avoid putting a tab right in this curved region. I would rather put it over here in this flat region. So I would remove this one and put a new one over here. Same with here. I would put one over here in the flat part and get rid of anything on the inside there. That's going to make it much easier to clean these up later. And this one here, we can click and drag and move it into a better location. Another thing I would mention about tabs is if you're working with solid wood, you have to pay attention to your grain direction. One solid wood in particular is oak or ash. Those are more of a porous grain, and I've actually had issues if I have the tab going with the grain. So for example, if the grain was going top to bottom in this example, this tab here would be weaker than a tab being on the end grain. So for example, one up here, that would be going across the grain. And I just find if you have a tab on the edge here going with the grain, it's more likely to break along that grain rather than having a tab up here going against the grain. It's going to be stronger. Keep that in mind if you're working with solid wood. And also, like I mentioned earlier, having bigger tabs is going to help with that as well. And once you're happy with your tabs, you can click close. And another thing to mention, if you want to use a different style of tab, there's also an option if you click show advanced toolpath options at the top of your profile toolpath. Now you're going to have the option to do 3D tabs. You can see that here by this check mark. The 3D tabs are going to cut quicker. So instead of stopping and raising the bit and going over and then dropping down and cutting again, it's now going to ramp up, ramp down, and keep going. So those ones will cut faster if you want to use those and cause less issues with your toolpath. So I would recommend doing 3D tabs if you can. Once you're happy with your tabs, you're going to click Calculate and then reset your preview. And now you can see the location of all those tabs in these toolpaths here. You can see where it ramps up and ramps down. That's the 3D tabs because we selected that option. Now if we click Preview and take a look at this, you can see all those tabs holding the material in place. And this is where you can get a good idea of what this would look like. And if you want to move these around anywhere, you definitely can. So for example, here's where the two tabs do not line up. You have one over here and then one over here. It's going to make it a little weaker here. So you may want to move this tab to line up with this one. Same thing with these two letters that are close together. You may want to move one of these tabs to line up those tabs a little bit better. That's all going to make everything stronger and held together much better. But those tabs will now hold everything in place and keep you from having any issues with these small parts falling out and causing any tool breakage, clogging of your dust collection, or just parts flying all over your shop. So this is going to be a much safer way to cut these. So hopefully that helps you understand those tabs a little bit better and how you can use them. Let's move on to mistake number 7, and that is not cleaning up your nodes or your vector quality before making your toolpaths. And I have this example for you. This is some wavy lines that we're going to be carving and this heart shape here. And you can see from the distance, it doesn't look too bad. But if you zoom in, you can see these waves are actually messy. And another thing I want to do is take this heart and offset it to create another shape that I'm going to cut to. So I'm going to select that heart and go to the offset tool. I'm going to offset it outwards by 1/2 inch and click offset and then click close. And you can see everything looks good from a distance. However, you'll see that original heart that we have, if I go to the node edit mode on that, it looks really good. It's clean and only a couple nodes. And this heart shape is from our clip art library inside of Vectric. But if we go to the offset one, you could see it is very messy with lots of nodes. And if you don't know what nodes are, that's basically all these points where your toolpath is going to create a line of G-code for each one of those. I like to imagine this line as basically a subway station route, and then each one of these dots is a train stop that's going to stop at. So just imagine if you had to travel along that whole route and you had to stop at each one of these, it's going to take you a long time to get to the final destination. Whereas if we had this other train route and we only had to make these couple stops here, you're going to get there very quickly. So it's the same thing when it comes to toolpaths. The less nodes you have, the quicker it's going to machine. Same thing with these wavy lines that we have. You can see they have a lot of extra nodes that do not need to be there. So the more nodes you clean up and get rid of, the quicker your toolpath machining is going to be, and also the smoother it's going to be. If you have really jagged lines or a lot of extra nodes, it's going to make your toolpaths not run as smooth and cause issues. And the reason we have that node issue when we offset the lines is because these lines are Bezier curves. And you can see that by these handles here. Anytime you have a handle like that on a node, it's going to be considered a Bezier curve line. So that line, whenever you offset it with Vectric, it's going to convert it into small straight line segments. And that's just the way Vectric does it when you offset a curved line. So you do have to fix that afterwards. If you offset a straight line or an arced line, it's not going to cause that issue. You can see if I draw a rectangle, these are going to be straight lines. And if I draw a circle, which is going to be considered circular arcs, and then if I draw a ellipse, the ellipse will be considered Bezier curve. So these are the 3 different line types you can work with. If we go to node edit mode, just type in the letter N, you can see we have straight line segments, we have circular arcs, and we have Bezier curves. So those are the 3 different types of line segments that you can have. So if we took all 3 of those and go to the offset tool and offset them all, and then click close, and if we take the original and the offsetted one and go to the node edit mode, you could see straight line segments are perfect, no extra nodes. Circular arcs, perfect, no extra nodes. Anytime you have a Bezier curve, this is when it's going to convert it into these line segments. And they're all straight line segments now. So now we have to convert these back to Bezier curves to have less nodes. So that's how we're going to clean these up. So I'll show you, if you select that offsetted one go to your tool in your Edit Objects menu. It's this one here called Curve Fit. You're going to select that tool and you're going to change it to Bezier curves. And the smaller tolerance that you make this, the more closely it's going to follow that original line, but also the more nodes it's going to have. And then if you make it a bigger tolerance, it's going to have less nodes, but also be further away from the original line. So it all depends on how important that original line location is to you, whether you turn that tolerance up or down. I usually like to start with 0.004 inches in tolerance. And then if you have sharp corners, you can keep those. And also where it says replace selected vectors, I would recommend turning that on because then it will delete the original and put in a new one. Keep an eye on which layer you have active because it will go in a different layer if you have a different layer active. But you'll see once I click preview, all of those nodes have been removed. So you can see if I undo that, these are all the nodes that are there. If I click preview, now we only have a few nodes. So when I click OK and go back to the node edit mode by clicking the letter N, you can see this is much better. Only a couple nodes, and this is going to carve much quicker and smoother. You could still edit the nodes afterwards if you need to, but that's a quick way to reduce those. So going back to our project from before, we could select everything and go to the Curve Fit tool, and you'll see all those extra nodes. This actually slows down your computer a lot too. You can see if you zoom in and out, it's going to make it really slow. So it's a good idea to save things before you do any operations like this because I've seen it crash computers as well when you try to convert these to curves because it takes up a lot of data. So just be careful of that. You may have to do them one at a time if you have a slower computer. I'm going to deselect the original heart by holding Shift and deselect that because that one's already really good. All the rest here have lots of extra nodes. So I'm going to click preview and you'll see that outer heart looks much better, but these curved lines still have a few issues. So I can deselect the outer heart. And now if I wanted to, I could change the tolerance. I'm going to make tolerance a little bit bigger and click preview, and you'll see that will reduce more nodes. Like I said, it will make your lines go a little bit further away from the originals, but it's going to be cleaner. So it all depends on how critical that is for you. Once you're happy with the amount of nodes, you can click OK. And then we can go to the node edit mode by clicking the letter N. You can see these are much smoother and crisper lines, and everything's much faster now. And you can see if you have any issues like this sharp point here, we can right click on it, click it to a smooth point to be able to fix that and make it look a little better. So you can still do a lot of editing to this. But like I said, this is going to speed up your toolpaths, make them cut smoother, and also keep your computer nice and fast while you're working on these projects as well. So those are a couple things to consider when working with vectors and making sure they're clean and crisp lines when you're ready to set up the toolpaths. Our next common mistake that we're going to be looking at is forgetting to recalculate toolpaths after you make changes. An example I'm going to show you for that is if we make a sign. Here's an example. I'm making a sign and I go to preview the toolpath and it looks great, although I find out I have a very major spelling error. And as you can see, it says lie, laugh, love. And this is a common sign people make that it says live, laugh, love. And you can see it's missing one critical letter that really changes the meaning of this sign. So if I did not catch that in my preview and I close this and then click save toolpath and I saved it as a G-code file to my computer or taking it to my machine, even if I cut this out later on, I would know this is incorrect. I need to make some adjustments to this toolpath. So whatever the case may be, it could even be it's a wrong size or anything like that. Anytime you need to make changes to an existing toolpath, always make sure to recalculate it. So I'll show you how to do that. First, let's fix this. We're going to go to the 2D view. We're going to go to our design tab. We're going to select the text and go to our text tool. This is going to allow us to correct this for that critical mistake we made. By the way, there is a spell check directly inside of Vectric. You'll see if I just type some random word there, it underlines it in red, and you can right click on it and go to spell check and it will give you some suggestions. However, in this case, my misspelling is still a word, but it's the wrong word. So in this case, I'm just going to add that letter that I need, which is the letter V. now it says the correct thing I wanted, which is live, laugh, love. And now I'm going to click close, and this is now correct. However, the toolpath is not correct. Even though we changed the text or any vectors, anything you want to change, the toolpath is still going to be the original that you have set up. So this is going to be the part where I mentioned it's critical to recalculate your toolpath. You'll see that toolpath we still have is there, and if I preview it again, it still says the wrong word. So I'm going to reset this, and there's a couple ways you can recalculate this. If you have a lot of toolpaths to recalculate all at once, you can click this button here that says Recalculate All Toolpaths. It's a green button here in the Toolpath tab. That will recalculate every toolpath you have in your project. However, if you have a lot of toolpaths and only one of them needs recalculated, that button is going to take a long time to recalculate everything when it only needs to recalculate one or two. So if you only have a few that you need to recalculate, you can right click on one, go to Recalculate, and you can either recalculate the one that you have selected, you can recalculate all of them from here as well, or if you check mark a few of them, you can click Recalculate Visible, and it will only recalculate those ones with the checkbox turned on. So you see, no matter which one you use, once we click Recalculate, it's going to give you a message if they did it successfully or not, and then you're going to click OK. And now if you go back to your preview and preview it again, you'll see now it is correct. And like I mentioned earlier, this happens too if you change the size or anything. Let's scale it down. And if we look at our preview and go back, you'll see it is still the original size. So anytime you make changes, just right click on it, go to Recalculate, and then reset the preview and preview it again. Always recalculate and preview anytime you make changes like that. That's going to show you exactly what you see here is exactly what's going to cut on your machine. Also, if you save your toolpaths outside of Vectric in an earlier step and you made changes like this, make sure you resave those toolpaths again and get rid of those old ones with the wrong G code because of that spelling error that we had. So recalculating toolpaths like this will help you save any mistakes that you possibly may make on your machine. So it's always a good idea to check everything before you save it and make sure everything is correct. Another common mistake that I see a lot of people make with using Vectric software is not adding ramps to your toolpaths. And this is not so much a mistake as it is a benefit for making your tools last longer and your machine have less wear, because these ramps are going to make it easier for your tool and your machine to cut your material. So if you're not familiar what ramps are, I'm going to show you an example. This is without a ramp. If I slow down the preview and show you, it's going to enter into the cut straight down and then cut out your shape or whatever you're cutting. And then when it exits, it comes straight up. And that's fine if you're just cutting out a piece of material like that. However, that entry cut going into your material, going straight down like that, is going to be tough on your machine. And that's because your bits are not usually set up to be cutting on the bottom. They're usually set up to cut on the sides of the bit. And plunging straight down into your material like that will also put pressure on your CNC machine and push up on it as you're pushing down. So that's going to cause some wear on your machine and also wear on your tools as you're cutting. This is where ramps come into play. If we open up this profile toolpath, you can see we have an option for ramping the plunge moves. And this is going to allow you to come in at a ramp rather than straight down into the cut. Most of the toolpaths in Vectric have the ramping option, so it's a good idea to add those when you can. And it's going to ask you for a distance. You can set that up. I would say at least double the diameter of your tool. That's a good reference point to start from. But a longer ramp is going to make it easier on your tool. So anywhere you want to make that ramp, it's not super critical on the distance. Just make it at least bigger than double the diameter of your tool. This example, I'll use a 2-inch ramp and calculate that. And you'll see this specific ramp is going to be a zigzag ramp, it's called. So if I reset the preview and slow this down and preview it, you see it's going to come in at a ramp and then zag back, go down at a ramp, and then cut out the shape. And the zigzag helps remove some of that material away as it comes down and then comes back. That's one option for a ramp. If you want some more options with different techniques, if we open up that profile toolpath again, click on the Show Advanced Toolpath options, there are many more ramps options to choose from down at the bottom. There is Smooth, which is just one smooth ramp in, that zigzag that we just looked at, or a spiral, which will go around the full length of your cut and the full depth as it's going down. So it's up to you which one you want to use. I typically use the smooth or zigzag the most, but the smooth one is usually my go-to. So if we set that one to smooth and then calculate it and reset the preview, you'll see now it's going to go one smooth ramp down and then cut around, and that will cut out your material. In this example, I have at a full depth pass. You can, of course, do multiple depths per pass, and it's going to ramp at every depth per pass. So this is just an example to show you what that ramping would look like. And then if you want to look at that last option, which is the spiral, you'll see this one does not give you the option to set a distance, and that's because it's going to ramp along the full shape of your project. So if we reset this and then preview it, you can see it's going to start ramping along the full distance, and by the time it gets to the end, it's going to do a full depth ramp. However, you could see it usually slows down your machine this way. That's why I don't typically use this one too often. It really slows down your cut. Some machines handle this better than others. You can try it out if you like, but in my experience with this option, it slows down the toolpath a lot. Just keep that in mind, and you see now it got all the way to the full depth, and it's going to go all the way around again to get rid of that rest of the ramp. Just another option you can use if you need to. That spiral one we just showed is really great if you're cutting circles or something like a hole. It spirals down into the hole as almost it's drilling that hole into your project. So just some things you can explore, but adding those ramps is going to make much better use of your tool and reduce the amount of wear and tear you have on your bits and on your machine. And the final mistake that I see people commonly make with Vectric software that we're going to be looking at is not avoiding clamps or obstacles with your toolpaths. And if you use clamps or screws or anything that holds down your material when you're cutting it out, you may have experienced this before or may even seen somebody else experience this. Your machine sometimes will go right over top of those clamps and crash into them, and you didn't know it was going to do that, and then it breaks your bit or damages your machine or ruins your project or all of the above, and it's definitely not a good day when that happens. So Vectric made a solution for this in their newer version 12 and above that makes it much easier to avoid those types of things. So you'll see this example here, we have some circles being cut out, and if I preview this toolpath, it looks great, and everything's cut out properly the way I want it. And if I were to see this preview, I could see that some spots for clamps, I can put a clamp down here at the bottom and one up here at the top. Those would be two great locations to add those clamps. However, if you did not pay attention to your toolpath preview, if we turn that preview back on, you can see the red line here is the machine stopping one cut, raising up and going to the next cut and then going back down. And that traveling over this area here would crash into a clamp if we had one there. One way we can avoid that is by having it raise higher by changing our safety Z height in the material setup. But if you still had a clamp there that's going to be an issue, there is another way to do this inside of Vectric software. And that is by drawing a shape, typically a rectangle. Let's say we have a clamp here. I'm going to draw a rectangle there. And let's say we have a clamp up here as well. So I'm going to draw those two rectangles to represent where I'm going to be adding clamps. You can also see these in the 3D view as well. So those are the areas my clamps are going to be, and you'll see the toolpath travels over those areas in both locations. And this doesn't have to be clamps, it could also be screws or anything you have in the way that you do not want your machine going near. So inside of Vectric, if you have version 12 or above, and if you're using a Pro version or Aspire, you're going to have what's called keep out zones. If you're using a desktop version, you're not going to have this feature, unfortunately. But you'll see inside of the toolpath tab, you're going to see this button here that says keep out zones. You're going to click on that. You're going to select those two rectangles that we drew earlier. You can do this in the 2D or 3D view. And you'll see Right now the toolpath is going across those two rectangles. And if we wanted to avoid those areas, we're going to click the create from selection. And you'll see now it makes those as keep out zones. And now we'll bend the toolpath to go around those. And it's going to make a clearance of 0 to start with. That means it's going to go where your bit is just going to go right to the edge of that. If you wanted to go a little bit more, you can add a bigger clearance, let's say 1/2 inch, and you'll see that will automatically update in your 3D view, changing where the toolpath location is. Now it is a 1/2 inch away from that line that we made. So this will allow you to keep tools from going into those zones and allow your machine to go much safer and not be worried about hitting any clamps or anything in those locations. And of course you can add as many as you need or remove them, totally up to you. And if you don't need them anymore, you can also click clear zones to get rid of those. But those keep out zones are going to definitely help if you use clamps or anything that will get in the way of your toolpaths. That's all the tips I have for you today. Hopefully you learned something that will help you avoid mistakes. I know I wish I had something like this when I started, because I definitely made a lot of mistakes when I first started with CNCs. And if you ever want to learn more on how to master Vectric even better, we have lots of online training programs and courses and memberships that you can join. We have the links down in the description. We have taught thousands of users how to use Vectric software more efficiently and make those projects that they've always dreamed of making. So if you want to join us, you can click down in the link below in the description. We would love to see you inside. Let me know in the comments if you found any of these useful.